Okay, girls, it's a new topic. There's about 6 people away today. It's chapter 6 from the Year 10 textbook, Quadratic Equations. First thing we're going to do is we're going to look at what a quadratic expression is. So, I'll just read through this and then I'll write some notes down in a minute, all right? Girls, a quadratic expression, can you see that on the board? Is it big enough? Do you need it bigger?
A little bit.
Okay. One sec. Shh. One sec, girls. Okay, girls, so far we've just looked at linear relationships such as y equals mx plus b or 3x plus 2y minus 5 equals 0. So in all the equations we've done so far, there's just been a normal y and a normal x in them. Okay, no squared or anything like that. Quadratic relationships, a quadratic expression is an expression in this form. Actually, girls, I'll just get you to copy that. Actually, yes, yeah. Can you copy what's in the grey box? A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, c are constants, a does not equal 0. And can you also write down that the highest power of x is 2. So I want that whole grey first box. A, B, C are constants, they're just numbers. So it might be 2x squared plus the B might be a 3. So it might be 2x squared plus 3x minus 5 equals 0. So where A, B, C are constants like numbers, okay? They tend to be whole numbers as well, okay? So A, B, C are positive or negative whole numbers. B and C could be 0, but A cannot be 0. So if it's a quadratic equation, it'll have an x squared as its highest power of x in it. I'm going to go back to my sheet in a minute and write down a whole heap of quadratic expressions for you. Okay, there is a difference between an equation and an expression. An equation has a left-hand side and a right-hand side, and it's got something equals something else. Because this is ax squared plus bx plus c equals 0, it's an equation. Equations have equal signs in them, and something on the left equals something on the right. So that's an equation. An expression would just be this bit that I'm highlighting here. An expression would be if I just wrote if I just wrote ax squared plus bx plus c with no equals 0. That's an expression without the equals 0. It's an equation once you put equals 0 or equals something else. Okay? That's a really good question. Girls, example 1 from the textbook. State whether or not each of the following is a quadratic expression. Girls, this has got a highest power of x squared. It's okay. It's a quadratic expression. The next one is highest power of x squared is... So you've got an x squared term. It's a quadratic expression. What about this one? Girls, let's expand. Look down here at the solution. Can you see it? X minus 3 squared is a quadratic expression because do you remember this is a perfect square? Isn't it the first one squared minus 2 times each of those numbers? Minus 2 times 3 times x is minus 6x plus 9. So, yeah. All right, ask a question now. Did you want to ask a question?
No, I was asking if you could zoom in a bit.
Yeah, I will. I'm just going to talk about it, then you can write it down. Okay? So, once I'm finished here, are these quadratic expressions or not? This is because it's got an x squared. This one is because it's got an x squared term in it. As long as it's got an x squared as its highest power of x, it's a quadratic. It's okay that this has got 5x and 3. Girls, this one doesn't have an x term, but that's okay.
But why is it okay?
Well, because A is, you know how, all right, girls, here. You know how we've got that, and it's of this form ax squared plus bx plus c, where a is 2, the coefficient of the x squared is 2. What do you think b is in this one? There's no x term, so b must be 0. 0 times x, there's no x term here. Look, girls, it's a quadratic. As long as you can see an x squared in it, it's a quadratic. This has got an x squared. This has got a 2x squared. It doesn't have to have the x term. It actually doesn't even have to have that minus 7. As long as it's got an x squared, it's a quadratic expression. This next one can be expanded to this. Remember we did perfect squares? That's got an x squared term. The last one is not. We don't have 1 over x squared. That's not a quadratic. That's actually some type of squared hyperbola of some sort that you'll learn about later. So the last one is not. We want it to be in the form ax squared plus bx plus c is 0, where a, b and c could be any numbers as long as a is not 0. Yeah. Yes, b and c can be negative. Look at this one here. A is 1, b is -6, c is +9. Can you see that? In this one, a would be 2, b would be 0 because there's no x term, c would be -7. In the first one, a is 1, bx, so b is 5, c is +3. All right? Now, all right, I'm going to just do some examples. Shh. Okay. You know what? You don't need to copy those examples. You'll be able to do the exercise on your own by just looking back. Right, I want to do some questions from... Girls. Exercise 6.2, solving quadratic equations. So in exercise 6.1, the main thing there was just to see what a quadratic expression was, as long as it's a term that's got an x squared in it. You're going to see by the end of this exercise which ones are quadratic expressions. Exercise 6.2, solving quadratic equations. To solve a quadratic equation of the form ax squared plus bx plus c equals 0, girls, that is always the form of a quadratic equation. So you need to know that's the general form of a quadratic equation. You need to know it. Ax squared plus bx plus c equals 0, as long as a does not equal 0. What we do, we make sure all the terms are on the left-hand side of the equation, and we would like a to be positive. It's much easier to factorize if a is positive. So girls, sometimes you might, I'll give you an example of that a bit later, all right? Step 2 is to factorize the quadratic expression, and this is where all that factorizing that you did earlier in the year will be revised. So we're spending the whole lesson on this exercise, all right? Factorize the quadratic expression. Part 3, we then solve the equation by putting each factor equal to 0. Girls, please. So, for example, if PQ equals 0. Now, what does PQ equal 0 mean? P plus Q, P minus Q, P... Good. In algebra, the only symbol you can leave out is a times. So if P times Q is 0, if something times something else is 0, doesn't one of them have to be 0?
Yeah.
So if P times Q is 0, then I could say P equals 0 or Q equals 0. They don't both have to equal 0. Sorry, girls, I'm just focusing. So, solve the equation. You'll understand what I'm doing in a minute. These are the rules. So to solve a quadratic equation of that form, make sure everything's on the left-hand side and that you haven't got like -2x squared. The a, which is the coefficient of the x squared, has to be positive. So I've got here that the coefficient of x squared is positive. That's what a is greater than 0 means. I did write it here. A is greater than 0, meaning the number in front or the coefficient of the x squared is positive. You then factorize. That's where we're revising all that factorizing stuff that you did earlier in the year. And then solve the equation by putting each factor equal to 0. Because if all of it's equal to 0 and it's factorized, then one bit is either equal to 0 or the other bit's equal to 0. Once I do some examples, you'll understand what I'm doing. Okay, let's start. Exercise 6.2, I'm just going to choose some questions. Okay. All right, I'm going to start off with some factorized bits already. All right, I've got question 1b. So question 1, solve the following. Here is B. We're going to start off with some really easy ones first. A bracket A plus 5 equals 0. And then we'll do another one over here. We'll do, okay. Girls, it doesn't matter that they're not x's. They can be, I'll do 1 plus. That's not actually k, I've changed it. There's just another example. Shh, shh, shh. Okay, let's get started. No, we don't expand. Girls, shh, shh, shh. Already step 1 and 2 are done here already. I'm only practicing step 3 at the moment. If a times a plus 5 is 0, then either the a is 0 or a plus 5 is 0. Girls, if a times, you know a bracket a plus 5 means a times a plus 5. So if a times a plus 5 is 0, then either the a is 0 or the a plus 5 bit is 0. Does this make sense? Because if you're multiplying these two things by each other, I don't want it expanded. A bracket a plus 5 means a times all of a plus 5. And if the answer to that problem is 0, then either the a has to be 0 or that a plus 5 bit has to be 0. Does it make sense? It could be 0 times 20, or it could be 100 times 0, or 100 times 0, or -6 times 0, or 0 times -10, as long as one of them is 0. You put or here, not and, or. So therefore, a is 0. What's the solution to this? If a plus 5 is 0, what does a equal?
-5.
You take the plus 5 to the other side and you get -5.
So you're allowed to have 2 answers?
Yes, you have to have 2 answers. Girls, now, can we stop for a sec? Very good question. Quadratic equations, because their highest power is x squared, or squared, if I expand this, Victoria, what do I get if I expand it? A squared plus 5a. See how the highest power is squared? You have to have 2 answers when the highest power is squared. If the highest power is cubed, you have to have 3 answers. If the highest power is to the power of 4, you have to have 4 answers. Yes. Because if a plus 5 is 0, I want a on its own. What do? Take it over to the other side. All right, next question. Shh, shh, shh. Girls, if z plus 8 times z minus 6 is 0, then either z plus 8 is 0 or, does this make sense?
Yeah.
Or the z minus 6 is 0. Can I have solutions? Take the plus 8 to the other side. I need the z on its own. I'm solving equations. -8 or z is -6 to the other side becomes +6. So doesn't this make sense? -8 plus 8 is 0. And if z is 6, 6 minus 6 is 0. Okay. I'll do 2 more from this exercise. Sorry, I do. Z is -8 or, so we go z equals -8, comma 6. I can just write it like that.
But how come in the other one you have 4?
I don't have 4. A is 0 or -5. There's my answer. That is the same. It's just the next line of working. All right, the next questions. These are just the basic type, girls. We'll be factorising in a minute. The next one, 3v plus 7 bracket. Actually, they're not exactly the same as those. I want to change the ones in the book a bit. 2v minus 3. Shh, they're not. No, I've changed it. It's similar. And the last one I want to do would be this. Okay. Okay. No, because I'm changing them slightly. But they're all from question 1, similar to question 1. Okay, what do I write here? Shh, girls, what do I write?
You write 3b plus 7 equals 0 and 2b minus 3 equals 0.
Or, sorry, I should write, or 2v minus 3 equals 0. Now I need to make, so 3v is what? And then therefore v is -7. What do I do with that 3? Good. -7 over 3. My other one is that 2v is?
It's -3 over 2.
No, it's not. You take the -3 over first and you get
It's just 3 over
+3. Do you see what I'm doing, girls? 2v minus 3 equals 0. Take the negative. We're trying to work out what v is on its own. So therefore v is 3 on 2. So here are my answers. V is -7 over 3, comma 3 over 2. The comma means or. It doesn't matter.
Wait, what happened?
I've got 2 answers. These are my answers.
Yeah, but are they always going to be fractions?
Sometimes they're fractions, sometimes they're whole numbers.
So for quadratic equations, we're
Two
trying to
answers.
find out what
The A or the
we're trying
Z.
to find out what A
The
is.
pronumeral, yes.
The pronumeral with the squared.
Well, just the pronumerals. Well, that's not squared yet. That would be squared if I expanded it. Look, Z squared minus 6Z plus 8Z minus 48. That is a Z squared. This is already in factorized form for you. These are quadratics because when you expand them, you get squared. Yes.
So we use this in order to do then trinomials.
Yeah, what we're going to do, this is the last step in the trinomials that we're going to do in question 2. We're going to do trinomials and that in question 2. All right? Questions 2 and 3. I'm just getting you used to that very last step. Okay, if I've got y plus 9 squared equals 0, you know how I told you there's always two answers? Doesn't that really mean y plus 9 times, I wouldn't normally do it like this, but y plus 9 times y plus 9 is 0. Isn't that what that means? There's only one answer, but I've told you if it's a quadratic, you always get two answers. The thing is, you get the same answer twice. Okay? So girls, therefore, y plus 9 or y plus 9 is 0. I only need to write it once. Does that mean? One sec. No. This is not a difference of two squares. This is a perfect square. So girls, if y plus 9 squared is 0, I could square root both sides, or I could write it that this is written twice. Y plus 9 squared means y plus 9 times y plus 9 is 0. In other words, y plus 9 is 0 or y plus 9 is 0. I'm only going to write it once. Therefore, what does y equal? And you know what? There are two answers. It's negative 9 twice, but you don't have to write it twice. So it really is y equals negative 9 or negative 9, showing that it's a quadratic and you would get two answers, but you don't have to write the same answer twice, okay? Just showing you that it does have two answers, but you only need to write it once in this case. All right, we're going to look at some examples from question 2 of exercise 6.2. Let's start. Question 2E. 2e squared minus 8e equals 0. I need to factorize that. I'm also going to do 2g n squared minus 9 equals 0. All right, let's go with the first one. They're not always trinomials. Can you just look for ordinary factorizing first? Anything in common between 2 and 8? Anything in common between e and e squared and e? 1e, what's left over? E, no plus.
A minus 4.
Let's just check our factorization. 2e times e
2a squared.
is 2e squared. 2e times negative 4 is minus 8e. So girls, this now becomes like question 1. What do I do? Girls, be careful. 2e is 0
2a equals 0 or a minus 4.
or e minus 4 equals 0. So therefore, e is 0 on 2. Girls, e's got to be 0. It's 0 divided by 2, which is 0. 2 times what is 0? What does e? 2 times 0 is 0, or what's e here? I need the e on its own. Girls, you okay with this? It would be 0 over 2, which is 0. Or that, you would just use common sense. 2 times 0 is the only way you're going to get 0. So therefore, your solution is e is 0 or 4. What about the next one? Do you recognize it? Now we're getting into our perfect squares, difference of two squares, trinomials. All right. Shh. If this, girls,
Is it n plus 3 and minus 3?
listen.
Alright.
Shh, stop talking. If you're not sure, see that question and this one. Two terms. When you've got two terms, you need to check for two things. Can I find a common factor? Try that. Obviously no common factors here. If there's only two terms and you've got a subtraction, difference, look for difference of two squares. That's n squared minus, can this be written as a square number? 3 squared. So now that definitely is a difference of two squared things. Two things that have been squared. Answer to the rule, girls, the rule is a squared minus b squared is a plus b bracket A minus B, if we remember that from earlier. So what does this equal? N
N minus
3, N plus 3. Obviously, girls, it doesn't matter which way you do it. So N minus 3 is 0. 0 or N plus 3 is 0. Therefore, N is 3 or N is negative 3. There's my answer. 3 or negative 3. Can you see it? Right. More factorization practice. We're going to do one of each of the 4 types. No, there's 5. Great. Thank goodness. We've got N. We need to just practice a whole heap of these. All right, let's do M first. Girls, the plus plus is the easiest type because you've got to get something plus, something plus. Do you remember how it was?
I did N first.
Shh, doesn't matter. Girls. Shh. Do you want the crisscross? You have to think what 2 numbers multiply to give positive 3. Oh, I don't mind the brackets either.
Yeah, I like the brackets better. I did N minus 1.
Girls, if you want brackets,
It's 3 and 1. It's 1 and 3.
yes, what 2 numbers multiply to give positive 3? It's positive 3 and 1. And add to give 4. 3 times 1 is 3. 3 plus 1 is 4. The answer is k plus 3, k plus 1. Now, let's just check. K squared plus k plus 3k plus 3 is 0. That adds up to that. So therefore, what have we got? K plus 3 is 0 or k plus 1 is 0. Therefore, k is what? Negative 3 or k is negative 1. Girls? Over there. Shh, 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 shh. Girls, when you've got a plus on the end for the number, but you've got a minus here, both numbers have to be negatives. Because 2 numbers that multiply to give a positive could be 2 pluses or 2 minuses. It has to be negative because you've got a negative in the middle. So what 2 numbers? I need M minus, M minus.
It's 3. It's minus
3 minus.
Well, the numbers that multiply to give negative 12 would be negative 3 and negative 4. Add up to give negative 7, but negative 3 times negative 4 multiply to give positive 12. So you've got M minus 3, M minus 4. Girls, do you want me to do the crisscross? Or are you okay with this? Shh. So just checking, ladies. We've got M squared minus 4M minus 3M plus 12. That does give me M squared minus 7M plus 12. So M minus 3 is 0 or M minus 4 is 0. Therefore, M is 3 or M is 4. Next question is, I'm doing Q,
Yeah, but when it gets to big numbers.
A squared. We're just doing easy types first. Minus 4A minus 21. S N squared plus 2N minus... Shh, ladies. With this type, we've just got A squared, N squared. I would just do my 2 brackets. They've both got to be A's. This one, if it's not a 2N or anything like that, these have to go like that. Now, where you've got negative 21 here, girls, one of them's got to be negative and one of them's got to be positive. Because 2 numbers that multiply to give negative 21 but add up to give negative 4. Now, don't worry about them being negative positive. Just tell me 2 numbers that can be multiplied to give 21. It's either 1 and 21 or 7 and 3. 7 and 3 can give you 4 somehow, or negative 4. So we've got 7 and 3 to start with, but if you want minus 4 as your answer, when you add them, you need more minuses than pluses. Minus 7. Now let's watch. Minus 7 times 3 is minus 21. Minus 7 plus 3 is minus 4a. 2 numbers that multiply to give your last one, but add up to give the minus 4. So we've got a minus 7, a plus 3. A minus 7 is 0, or a plus 3 is 0. Therefore, a is 7, or a is negative 3. Shh. Girls, if people are waiting and they know what to do, you know I'm going to set you the last column, okay? So I'm just picking a few questions in between and I'll be setting you the last column for homework. What about this one, girls? I want two numbers that multiply to give negative 24, but add up to give positive 2. Now just think all the factors, 24. Would it be 1 and 24? 12 and 2 will only give me... Yeah, see, 12 and 2 can only give you 14 or 10. Add them together, you'd get 14. Subtract them, you'd get 10. Ladies, times tables, 24. What gives you 24? Is it going to be 1 and 24? No. 1 and 24 can only combine to give 23 or 25 if you added or subtracted them. 12 times 2 could only give you, the 12 and the 2 could give you a 14 or a 10, depending if you add or subtract them. I don't care about the sign yet. 6 and 4 could give you 10 if you added them together, or if they were subtracted somehow, it could give you 2. Now that looks like it's the right one. So I need, but one of them has to be positive, one's got to be negative. So I've got 6 and 2. 6 and 4. No, it's not. If you want more, if you want plus 2n, you need plus 6 minus 4 when you add them together. I want plus 2 to be the addition of these two. So I need more pluses than minuses. Plus 6. So we've got n plus 6, n minus 4. So n, girls. So n is minus 6 or n is 4. Shh, girls. Right, ladies, I'm doing question 2V, which is, girls, we're just going to keep doing these. That's all we're doing for the rest of the day. But we're doing the non-monic in a minute. Shh. P squared plus, girls, please, plus 6p plus 9 equals 0. And I'm doing W. H squared minus 10h plus 25 is 0. Let's go. Shh, girls. Okay, girls. You know what you should look for? If that last term, like that 9, is a perfect square, it could be a perfect square. This could be p plus 3 squared. But you can just do it your normal way if you want. Girls, what two numbers multiply to give positive 9? 3 times 3. But add up to give positive 6. So it's p plus 3. So what two numbers multiply to give, girls, they're both pluses. Everything's got to be pluses when they're both pluses. So girls, isn't that really p plus 3 squared? You didn't have to write that. Some of you would be able to do this straight away. Do you know what I mean? So a lot of people don't go from this first line to the second one. They just go straight to there because they recognise that 9 is 3 squared and that the 6 is double the 3. Don't worry, we're doing completing the square later in the week. So, girls, therefore, p plus 3 is 0. What's p? And this one, what have you got? Two numbers that add up to give, girls, it's not plus 5 and plus 5. So, what is it? H minus 5. How can I write that simply? Perfect square with a minus. So, therefore, what does H minus 5 equal? What does H equal? Okay. All right, some more questions. Question 3B.
Wait, 3B, are we doing? Are we doing the 3B?
Yeah. And 3.
Is that it for all the questions?
I'm making one up.
Oh, she's making one up. She's making one
It's not hard.
Can you swap the sides for 3B?
You probably don't need to with this type. I know. Shh. Excuse me. Girls, question 3. Now, I did say if it's a c squared, I prefer you to swap the sides, but mainly if it's a trinomial, not a binomial. But shh, You can if you want. See how the c squared here is negative. You could take everything to the other side and solve if you want, but you don't have to. Well, let's just try and see what the common factor is. Let's just try and factorize c bracket. Now this one's okay to do this way, okay? I'm going to show you that if, so therefore c is what? Or minus c is 0. Be careful, take that c to the other side now. C is 0, or just look at it and tell me what c would have to be here. 8. Can you see? 8 minus what is 0? Now, I want to show you, this is the problem with having the minus c squared. The other thing you could do with this question, but I don't think it's necessary for this one, but just watch, but we will do it for trinomials. I don't want you having questions like up in question 2, let's say if this p squared was negative, I don't want you working with it that way. If I don't want a negative squared term, I can take everything over to the right-hand side, and what do I get? The negative c squared becomes positive c squared, and the positive 8c becomes minus 8c, and I get equals 0. So I'm just taking it over, but then again putting equals 0 after it, because we don't like putting equals 0 before it. Those are both true. Now I factorize out the c, and what do you get? So this is another way of doing it. Bracket c minus 8 is 0. So therefore c is 0, or c minus 8 is 0. See how it's easier to take the 8 over? Or c is 8. Isn't that the same answer? C is 0 or 8. Same answer. Now, okay, this one, next one.
Would we expand it?
No. Girls, factorized form is where you go from. 6 minus, I've just made it up. 6 minus 7t squared. So that means, it's this, I'll rewrite it. So, what do I write on my next line? You don't have to write them twice. 6 minus 7t is 0. No, expanding. No, girls, when you're solving these, factorized form is one step from the end. It doesn't matter. Oh, so you want to write it as that times this? You don't. So therefore, 6 minus t is 0. Now, what do you want to do?
Wouldn't you do 6? Take it out of the bracket.
Yeah, you can.
Wouldn't you put 7 0?
Can you take that 7t to the other side? I don't want negatives.
Yeah, equals 6 over.
So therefore, t is? I prefer it like that. Don't take the 6 over and get negative 7t equals negative 6. You're going to get into a big mess. I'll show you if you do that. Ladies, can I just show you something, please? If you've got this step, I would definitely take that minus 7t over to the right. If you don't, you're going to be left with this. If you keep the minus 7t there and take this 6 over, what do you get? Minus 6. And then what do you have to divide that minus 6 by? And then what's minus 6 over minus 7? Now, isn't it just much better just to take the minus 7t over and make it a plus 7t here? And therefore t is 6 over 7. Girls, so many people will mess this up. They'll think the answer is negative. But I prefer that you go this way. I mean, they're both correct, but if people think, you know, you don't have to have your pronumerals on the left. It doesn't have to be that regimented, all right? You can take the pronumerals to the right if it makes it easier. Yes. No, then you've made a mistake. You'd lose marks. You'd lose a mark if you got it wrong. Okay, girls, next. Shh. Girls, more questions?
The last one.
Same exercise. This is question 4a. Girls, I've chosen easier ones because 2x squared, you need the factors of 2x squared and you need the factors of 2. I want to do this with crisscross. Now, or, yes I can. So girls, what multiplies to give me 2x squared? 2x and x. Ladies, stop. All right, if you want, you can just go like this. Shh, girls.
what's the other method? Yeah, that's what I like. I don't know.
Is everything positive here?
Yeah.
This is the, no, you don't have to divide by 2. You go plus, plus. Do you know why it's plus, plus? Because everything's plus. Girls, what are the factors of 2? What? Now, you've got 2 choices. If I put the 1 there and the 2 there, let's see what we've got. Just watch. 2x times 2x is 2x squared. 2x times 2 is 4x. 1 times x is... So that 2x times 2 is 4x. 1 times x is 1x. So I get 4x plus 1x is 5x.
Yeah.
So that's the correct way. If I put the 2 there, do you want me to show you the other way? Let's say you decided you've got 2 choices, girls. You've only got 2 choices here. You've either got 2x and x with a 1 and a 2 there, or you've got the 2 and the 1 there. There's only 2 possible combinations. If I do it this way, I get 2x squared plus 2x plus 2x plus 2. Now, plus 2x and plus 2x gives me plus 4x, not plus 5x. That's wrong. So, I look over here and I try the 1 here and the 2 there. 2x squared plus 4x plus 1x, that's plus 5x plus 2. You okay? 2x plus 1 is 0, or x plus 2 is 0. What have I got here? 2x is negative 1, x is negative a half, x is 2. So girls, I would only do it with these types where you've got a 2x squared and a 3u squared, girls. Tell me.
I was just wondering, could you just tell me, like, just quickly how you do that, not Christmas method, the other one? Do you have to multiply the coefficients?
Yes, I'll show you numbers that multiply to give that go at the front. It's got to be 3u and u. Now, girls, let me just worry about 3u squared, 3u and u. Now, I've got 2 choices for 10. I've got 5 and 2, 2 and 5, 10 and 1, 1 and 10. Before you start putting them down, girls, if I put 2 here, I've just worked it out, and 5 there, look, 3u squared, that's a 6u, and that's a 5u. Now, if this is positive, but that's negative, how do you multiply 2 numbers to get a positive? They've either both got to be positive, or they've both got to be negative. When you've got a plus on the end, plus the constant, either these are both going to be plus, or they're both going to be minus. Because I need 2 numbers to multiply to give 10. It's minus. So I've got 3u squared minus 6u minus 5u is minus 11u plus 10. Girls, I'm giving you the homework now. Homework is, ladies, homework, exercise 6.1, I think it was just question 1 only. Exercise 6.2, last column, questions 1 through to 4.